At the top of the Greenland ice sheet, you only get that much. But in the southeast part, you get about that much, about 2 meters of precipitable water as ice there. So it's a local effect, but it indicates that if the ice sheet was lower, that you'd have a lot higher precipitation spread over a larger area of Greenland, indicating that when the ice sheet was growing, just by atmospheric science today or meteorology today, that you'd have a lot higher increase of snow and ice. But that's what it says, that during the Ice Age, when it was starting to build, it would be fast, even in today's climate, if you got rid of it. But it doesn't say too much about the current conditions, because at the top, because we got measurements up there and it's a lot less precipitation at the top. And that's where they have the ice cores. The ones that they are significant ice cores are at the top. So thank you for that question.
Just a couple more questions.
Okay, yes.
Could you please just give one nugget out of that plate tectonics book? I don't think I have time to read it. I'm a homeschool mom and I'm taking 9 credit hours at college, and one of my classes is geology, and which I'm not enjoying. And the whole thing really is built on that plate tectonic model.
Okay. I've done a lot of study in trenches, and that's one of my 2 chapters in there, trenches. And before they examined trenches by seismic methods and by drilling, deep sea drilling project, they had some simplistic ideas of how subduction zones, see trenches like the Marianas Trenches or the trench off Peru and Central America, they go parallel to the coast. And they believe it's where one plate is diving under another, like this right here. Okay, if that is the case, then there should be a lot of features that indicate convergence of 2 plates, whether they go under or not. There should be convergence effects, convergent geological effects. Well, the more they know, the more they're realizing that it's just the opposite, extensional effects, as if trenches are just simply downdrops, or grabens as they call it in geological jargon, because we know it's for sure we have extensional features on the downgoing plate. That's well known. No problems there. In the trench, we either have no sediments or very little sediments, or we have thick sediments that are parallel like that and that have normal faults, which is an extension feature. And flat sediments indicates, if they're deposited over 100,000 years, indicates no convergence, but actually right in the trench itself, extension. Now the most significant area is where it's diving down like this. It's supposed to plaster ocean sediments onto the continental side like that. It's called an accretion prism. That accretion prism is supposed to be a high percentage of ocean oozes and stuff like this, but it's mostly sediments that came from the continent, just the opposite. And not only that, the more they probe, the more they're seeing extensional features in that accretion prism. Instead of convergent features where it's plastered on, it's extensional features like slumps. It's just really slumped. And normal faults, normal listric faults. It's a lot of slumps, and the more they check that, the more they're seeing this. I have some pictures in here of some of that, but that's what they're finding. So the upshot of this, instead of converging, they're finding just the opposite, extension, and I think that's some pretty strong evidence against it. But yet, they will fit it into their paradigm with some more exotic hypotheses, which include what's called abduction, where it's actually tearing off part of that upper plate and taking it down, and that causes the extension and the sinking of the land. That's another thing. They found that instead of plastering it should go up, a lot of it is sunk. So they find a lot of anomalies. That's just one that I've researched myself, and I don't think the data on mid-ocean ridges is as they expect, because they can't hardly find any molten lava down there. See, the lava is supposed to come up in the mid-ocean ridge as the ridges spread like that, and use plaster lava. I don't think the features you see go along too well with that, but especially when they probe by seismic reflection profile those ridges, they don't hardly find any molten lava. And when they do, it's spread out 200 miles wide around it, not right in the center, spread out like this. And they say, well, now we got to gather it like this to come up like that. So there's lots of problems that you don't hear about until you read deep in the literature. So those are just some of the things. And I believe that both of those, the trench, I have an article on trenches, and I also mentioned the mid-ocean ridge problems in here and other problems. So that's just a quickie on that. But I'm doing more research. I think I'm going to write a paper on mid-ocean ridges when I get time in 2 years. Yeah, I got a lot going on right now. I think I have one more question. I want to get someone that hasn't asked. Okay, yes, back there.
The earthquake last year that caused the tsunami, they discovered that there was a mountain range formed in like minutes. It's like 5,000 feet high. There was also a big trench next to it that opened up. Has that, I mean, I know that changes a lot of the geological theory, but has that helped you guys with your theories?
I haven't had time to look at it. First of all, it happened near the Java Trench, if that's what it's called. It might be called some other name that far north. So the trench was already there. Okay, I heard of some big uplift under there, but I can't remember the details right now. And I haven't had time to go into it. I know one thing I read that's really interesting is in some of those Southeast Asian countries, they found plants, after the tsunami left, they found seeds that were spread there from the tsunami of plants that only grow in the southwest United States. Creosote bush, I think, was one of them. They were growing there, and they got there somewhere halfway around the world. That, I think, could give us some indications on dispersal after the flood.